Hello again, YouTube. The last time I created an MCU Espresso project for Morse, just basically because I felt that this is my GitHub project here, CB Getting Started, and if I look at the directory structure, the directory structure was tightly coupled to an MP Lab X project. So it meant that it would have been difficult eventually to move to another development environment or to another platform, another hardware platform. So last time I created an MCU Espresso project just to split this up, make this directory structure and the GitHub project more flexible. So I never actually showed you the project, what the actual MCU Espresso project was destined for, and that's this OM13085 development board from NXP. So it comes complete with this debug part. So the left hand side of the board here is the debug tool, and you can flash code into the actual device. You can actually split the PCB if you wanted. And there is supposed to be a jumper on here that was broken off in transit when I received this one, but you can actually, if you had the jumper and shorted it out, then it disabled the debug unit. So I don't have that feature, but it's just a handy little toy to play with, because all you need is a micro USB cable and it's got debug and everything built into it, so you can actually then play about within the IDE. So if I plug it in here, should see a LED, and you should see that device there is going to be the development board. So the reason I'm doing this again, I'm doing another this channel is about my own development board, the cinnamonBun. The reason I'm doing going straying off into the weeds again is because I want to look at libraries of code. So a device is important, the actual microcontroller that you're using, the processor is important, the features it has, but the software that comes with it, the associated software, both in terms of compilers, linkers, debug capabilities, integrated development environments, and also libraries of code, so you can actually speed up the development time. If you don't have a library of code, then you have to read through a user manual like this. Like for this family of devices, including the LPC1769, I've got an 851 page document here. So if you want to create something, you've got to go through this, work out what registers you have to set to what values in order to achieve what you want to achieve. Now if I go through to chapter 21, which is the timers, you've got a number of timers. This is for 0, 1, 2, 3. Now there may be other timers I haven't checked, but for timer 0, 1, 2 and 3, you're going to have a register set. So there's your special function registers that you configure these timers. So each one of these 4 timers, so the interrupt register IR, you're going to have a timer 0 IR, timer 1 IR, timer 2 IR, timer 3 IR, and this is their address in the address map. So you have to set various values at that address to achieve what you want. But in order to do that, you've got to read through this document and work out what it is you're doing, or what you need to do, what values you need to set up. So do you want the timer to increment on a rising edge, on a falling edge, or both? These are the kind of questions you have to go through and answer. To save you doing that, you would use a library of code which already does that for you, and hopefully speeds up the development time. So if we look at, we're looking at a 1700 series. Now the one thing I haven't been able to get is user documentation, because there's 4 user guides but all they are is quick start guides, and well, there's a porting guide for version 2 to version 3, but there's a quick start for the Kyle and a quick start for the LPC Expresso. Now the LPC Expresso, as far as I know, is the older version of the IDE, and MCU Expresso is the later version, but I might be wrong because I don't use NXP equipment as a daily driver sort of thing. The other version is an IAR documentation, so I'm not sure about the level of documentation. If you actually go in and look at the chip project that we had in LPCOpen, we have a timer file there, and there are 5 API functions to help us create a timer. Now I'm going to try and import a project, and to save me writing, I'm going to pull in an example project. I previously pulled in the board and the chip, so I'm going to try and pull in. There is a timer example in this project here. If I deselect all, I just want that project. So this project, uses a timer to generate a periodic interrupt. So the interrupt handler will blink the LED. So that's exactly what we want. And this, hopefully, so there's the interrupt handler, which basically uses one of those API functions, match pending. Ooh, match pending isn't over there. There must be another timer. There must be another timer code somewhere with more API functions. I wonder, can I... I'm not getting the declaration. Oh, I am. Oh, sorry, there's a load of inline. Right, there's a load of inlines defined in the header file as well. So there are a number of API functions in both the C file has 5, and then the header file has quite a number of inline functions. So there's quite a number of API functions. I thought 5 was a bit limited, but so our project, the example project, matches an interrupt and then clears that interrupt, and then we'll toggle the LED. And the main just sets up the system, so set up the clock, initialize the board, initialize, that's an API function to initialize the timer structure, and that timer is at address, you can see address there, 4000 hex 4000, and that is so that's that address there. So timer 0, the first register in timer 0 is this timer 0 interrupt register, and that is what is being initialized. So that whole structure has been initialized there. So then we just reset that timer match enable an interrupt and then set match. So that function set match, I assume match value for the selected match count is the timer frequency, which is got from another API function, divided by the tick rate, which I think was defined. Was that defined at the top? Yeah. So we want 11. I think that if I change that to 1, then we should get 1 LED flash every second. So it'll be a second on, a second off, I assume. So that's us. And we drop into our infinite while loop that just does nothing but wait for interrupts and process interrupts. So if we build this, and now if I debug it and drop it into my OM13085 device, that should be it, ready to go. So if I just pull this, across, and if I set it always on top, then if I resume execution here, right, you've got the LED flashing on the debug side of the board, and you've got the red LED which is on and off for a second. And that was all I wanted to show you, just because these the timer API functions that are provided in LPCOpen. Now, they improve your development, they make it easier to develop, because they should be more convenient than actual reading through 851 page documents every time you want to do something. And that's all I wanted to go through, because part of the cinnamonBun is a library of code, and that library of code and the functions, the API functions associated with it, are as important as the actual functionality of the device, and is equally, if not more important in some ways, because it will help speed up a development process as a result. So thanks a million for watching. Hopefully that makes some sense, even if there's very little documentation for the LPCOpen. That sort of explains what this library of code would help you do. Once again, thanks a million.